Alright guys, so now we're going to solve logarithmic equations. So in the previous video we solved exponential equations, so now we're going to go ahead and solve logarithmic equations. So let's take a look at number one. So again, what we're trying to do is solve for x, which means we got to get rid of everything that's with it. Well, the first thing that I can do, because I have this multiplication here with the 2, is I can go ahead and divide both sides by 2. So that would give me log base 5 of 3x is equal to 2. So now we're saying, well, how can I get this by itself? At least get rid of the log to base 5 in order to continue on and get that x by itself. Well, remember that logarithms and exponents, they're inverses, opposites of each other. So what I can do is I can do 5 raised to log base 5 of 3x to both sides. And by doing that, this will go ahead, that goes away, they're undoing each other, and I get 3x is equal to 5 squared, which of course is 25. And now I just have one step left. I can divide both sides by 3, and I get x is equal to 25 over 3. All right, let's take a look at another one here. So now we have 2 log expressions in here. So think about the properties of logarithms. What I want to do is get these together into one log. Well, basically we want to condense this. So with the properties of logarithms, when you subtract logarithms, it's the same as the division when we condense it. So this would be log base 4 of x over x minus 1 is equal to 2. Well, now that I have this one log expression to base 4, I can go ahead and do 4 raised to log base 4 of x over x minus 1. So do the base of 4 to both sides, the exponential function there. And of course, this will go away, they undo each other, and I wind up with x over x minus 1 is equal to 4 squared, which is 16. Well, now from here, I'm just going to go ahead and solve. So I can multiply, because now the log is gone, and I get x is equal to 16 times x minus 1. And then, of course, distributive property. So x is equal to 16x minus 16. And then I'm just going to bring this up here just for some room. So I want to get the x's by itself. So I'm going to go ahead and subtract 16x to both sides. And that gives me negative 15x is equal to negative 16. And the last step, we're just going to go ahead and divide by negative 15. So I get x is equal to 16 over 15. And that is done. All right, let's look at one more. So here we have the 2 log expressions terms here, but they're on opposite sides. Well, what I want to do is get them on the same side so that I can go ahead and use the properties and condense those logs like we did in the previous example. So I'm going to go ahead and add this log to both sides. And what I get is just log of x plus log x minus 3 is equal to 1. So if you recall, addition with logs is multiplication when we go ahead and condense it. So this is going to be log x times x minus 3 is equal to 1. And now since they're combined, I have this one log expression. I can go ahead and do the inverse. which would be an exponential of 10. So I'm going to do 10 raised to log x times x minus 3, because remember, what's not written here, we know this is the common log, which is base 10, is equal to 10 raised to the first, which then, that's gone, and it gives me x minus 3, sorry, x times x minus 3 is equal to 10 to the first power, which is 10. And then we continue solving, and you'll see when we distribute that we wind up with a quadratic. We wind up with a quadratic. Well, hopefully this is factorable. So I'm going to go ahead and move the 10 over. And I get x squared minus 3x minus 10 is equal to 0. So I'm just going to bring this up here. And it is factorable. So this factors to x minus 5 times x plus 2. And of course, when we solve, we set those equal to 0 and solve each one. So we add 5. So we get x is equal to 5. And then we subtract 2. Get x is equal to negative 2. Now we want to go ahead and check these to make sure that they're both going to be true, or maybe none of them is true. This could be no solution. So you plug in x equals 5 into your original here, and you'll see that it is true. You'll see that this is actually true. Now when you plug in the negative 2, you can look right away up here, and if you plug in and you have log of negative 2, well, that's undefined. So I don't even have to continue on. I know that this is not a solution, and my only solution is x is equal to 5. All right, so hopefully this helps you solve the logarithmic functions when we're solving those equations. And we will definitely move on from exponential and logarithms, and I'll see you on the next video.